This time, I'm going to talk about how to train a neural network and make predictions with Python. When we train a neural network, we will following these steps. 1. Taking the input data. 2. Making a prediction. 3. Comparing the prediction to the desired output. 4. Adjusting its internal state to predict correctly the next time. We use vectors, layers, and linear regression for our neural network. The data is stored as vectors. Each layer transforms the data that comes from the previous layer. You can think of each layer as a feature engineering step, because each layer extracts some representation of the data that came previously. Working with neural networks consists of doing operations with vectors. You represent the vectors as multi-dimensional arrays. In this video, I'm going to use two-dimensional arrays. Think about this. You have an input vector, and then you have weight 1 and weight 2. You want to adjust weight 1 and weight 2 to make your prediction. Vectors are useful in deep learning mainly because of one particular operation, the dot product. The dot product of two vectors tells you how similar they are in terms of directions and is scaled by the magnitude of the two vectors. Let's think about those two vectors, vector A and vector B. The dot product of vector A and vector B are calculated as the length of vector A and the length of vector B times cosine of the theta of the angle between those two vectors. The angle between vector A and vector B is very critical. When the angle theta is an acute angle, the dot product of vector A and vector B is positive. But when the angle theta is a right angle, and then the dot product between the two vectors will be 0. And when the angle theta is obtuse angle, the dot product of those two vectors will be negative. That's why we can tell how similar vector A and vector B is by calculating this dot product between those two vectors. In this video, I'm going to build a very simple network with two layers. First, we have input and we have the weight with the initial value. And I'm going to calculate dot product and get the result, and then calculate the sum with bias and produce layer 1 result. And the layer 2, we are going to have this sigmoid function. In my previous video, I explained sigmoid function in more detail. If you haven't watched that video, you are welcome to watch that video too. And after the layer 2, we are going to make our prediction. In my previous video, I explained what is activation function. This time, I will explain what is loss function. The error for the current state of the model must be estimated repeatedly. This requires a choice of error function, or called a loss function. Let's take x as our input and y as our output. This best fit line is our target. And of course, we are going to have our prediction for each data point. For example, this estimation has a difference comparing with this best fit line. And this difference, we can call it residual error. Then we will calculate MSE with this formula. We are going to square the difference between our estimation and the best fit line and sum those up and divide it by number of data points. Our goal is updating the weights for our model so we can reduce the loss on the next evaluation. When we calculate MSE, we are going to have those two steps. One, compute the difference between the prediction and the target. Two, multiply the result by itself. Now, let's consider how can we reduce the error. The error is given by the y-axis. If you are in point A and want to reduce the error towards 0, then you need to bring the x value down. On the other hand, if you are in point B and want to reduce error, then you need to bring the x value up. How do we know which direction we should change the x value for the next estimation? Derivative can help. If the derivative is negative, we know we need to increase x value. And when the derivative is positive, and then we know we should reduce x value for our next estimation. When we train our neural network, there is another concept called learning rate. After we made our first estimation here, comparing with our target, we need to update the parameters of the model for our next estimation in order to get better results. The learning rate is a hyperparameter that controls how much to change the model in response to the estimate error each time the model weights are updated. Of course, we can change it slowly, and in that case, it will take long training process until we reach this target. And if we change the parameter too much, and the next estimation might oscillate around this target like this, we are going to choose the best learning rate like this. It will come down, and then the second time it will reach this target. Now, let's go to Python to see how can we implement the algorithm I just talked and to train our neural network model. We have our input vector here, and then the target is 0.5. I give weight 1 some initial value here, and we are going to check how can we pick up our learning rate. And I put a critical value here at 0.0001. That means if the error is under this critical value, I'm going to stop training my model. And then I define the sigmoid. I will make prediction with this function. And here I'm going to calculate derivative in order to make adjustment. The adjustment will equal to the derivative and times learning rate. That means if the learning rate is small and I'm going to change parameters little by little. But if learning rate is large, I'm going to change it dramatically. Now, let's run the model. First, I'm going to use learning rate 0.05. You can see I start the value from here, and then, although it's hard to read because the data points are too close, we can see this is the 5th time, 6th time, 7th time, and then getting closer and closer to our target, 0.5. And if you want to check the value, you can check the value here. You can see we have 12 steps in order to reach our target. And if I change the learning rate to 0.01, that means I'll make it smaller. You can see now the data points moved slowly, and we can read this is 31, and then the step 32, step 33, etc. And in total it used 69 steps. And if we change the learning rate to a large amount, (0.15), you can see this is 1, this is 2, and this is 3. This is what I talked. If you change the parameter too much, the result will oscillate around the target. You see 3 is on this side, 4 is on this side, 5 is on this side, if you compare with our target 0.5. How about we change the learning rate to 0.2? You can see here 1 is here, and although this is hard to read, you can see 3 is here, 4 is here, 5 is here. That means it can never reach the target because the learning rate is too large. And when it reaches step 100, I just terminate this training process. As you see, I put condition here, otherwise it will keep going forever. And if we choose the learning rate as 0.1, you can see this is step 1, step 2, step 3, 4, step 5. And with only 5 steps, we can get our target already. So if we want to choose a good learning rate, we should take this one. This is how you can train a neural network model and make predictions with Python. Please provide your comments and subscribe to my channel. Thank you very much for watching.